Hello everyone. In this video, I am going to derive the Euler's equation. So the Euler's equation is a necessary condition for the integral I(x1) to x2 f of x comma y dash into dx, where y of x1 equals y1 and y of x2 equals y2 to be extremum is that dou f by dou y minus d by dx of dou f by dou y dash equals 0. So to prove this one, so I will draw an x-axis, draw the y-axis, x-axis, y-axis. So take 2 points, P of x1, y1, and another point, Q of x2, y2. So you join these 2 points using one curve. So using the another curve. So this is the point Q. So this line, this is the y1 and this distance is x1. Here you take another draw this. Up to here it is y and here it is x. And here, so this is x2 and y2. So this curve is denoted by y of x. And this is h into alpha x. The width is given by h into alpha x. Whereas this is y of x plus h into alpha x. So now, so let I be an extremum along some curve y equals y of x passing through the points P of x1 comma y1 and Q of x2 comma y2. So this is the extremum which is passing through these 2 points P of x1 y1 and Q of x2 y2. So let us consider one more curve, that is this one y of x y of x plus h into alpha x. Let y is equals to y of x plus h into alpha x be the neighboring curve joining these points so that we must have alpha of x1 equals 0 at P and alpha of x2 is equals to 0 at Q. Means, see, these two curves coincide. So this becomes, see, if this is 0, then only y of x becomes, this coincides with this line. So therefore, at this point, at P1, at P and Q, this term will be 0. That is alpha x1 and alpha x2 are zeros. And also when h is 0, these two curves becomes same. This also becomes y of x. That is when h equals 0, these two curves coincide, thus making I an extremum. So now write down the integral. The integral is integral I is equals to integral from x1 to x2 f of x comma y of x plus h into alpha x and y dash of x plus h into alpha dash of x into dx, because this is nothing but f of x comma y dash. So x comma y dash means what we have taken, this is y equals y of x. So if you differentiate, it becomes y dash of x plus h into alpha dash of x. So now, so di by dh is equals to 0 when h is equals to 0. Treating I as function of h. See why we will take this one while finding the maxima and minima. So this is the concept we are going to use it. So you might have aware of that how to find the maxima or the extreme values of a function. You can refer that. Now, if I differentiate this integral, that is, if I differentiate it, that is di by dh will be equal to integral from x1 to x2, it becomes dou by dou h, because it is called the why it becomes an ordinary derivative. It is called a differentiation under integral sign. So this d by dh here it becomes partial derivative. So x comma y of x plus h into alpha x comma y dash of x plus h into alpha dash of x into dx. So this should be equated to 0. That is, now I'll apply the chain rule. Chain rule in the partial differentiation you might have studied. So that is dou f by dou x into dou x by dou h plus dou f by dou y. Now x, y and y dash. So into dou y by dou h plus dou f by dou y dash, dou y dash by dou h. So this similar type of chain rule you will study in differentiation of composite functions. So what we have, x is x is independent of x is independent of h. So which implies dou x by dou h is equals to 0. And also we have this what is that, y. So what is y? Y is equals to h y of x into h into alpha x. So which implies what will be dou y by dou h? Partial derivative means this becomes constant, so it is 0. H derivative will be 1 into alpha x. So it is alpha x. And similarly, we have y dash. Y dash is equals to y dash of x plus h into alpha dash of x. So therefore, dou y dash by dou h. So this will be 0. H derivative is 1 into alpha dash of x. So it becomes alpha dash of x. Now I will substitute this and I will equate, okay, now I will substitute in that this equation. So that di by dh is equals to integral from x1 to x2 dou f by dou x, and this will be 0 because of this here. Here I have written dou x by dou h plus dou f by dou y into here dou y by dou h, it is alpha x plus dou f by dou y dash into dou y dash by dou h is alpha dash of x into dx is equals to 0. So, but di by dh, by dh is equals to 0. So, therefore, what we will get? We'll get integral from x1 to x2 dou f by dou y into alpha x plus dou f by dou y dash into alpha dash of x dx is equals to 0. It is given. That is what, okay. So now I will write it into two integrals. Integral from x1 to x2, dou f by dou y into alpha x dx plus integral from x1 to x2 dou f by dou y dash into alpha dash of x into dx, that is equals to 0. So now what I will do, I will apply the integration by parts for the second integral. I will treat this as first function and this as the second function. So it becomes integral from x1 to x2 dou f by dou y into alpha x dx plus first function, that is dou f by dou y dash into alpha dash integration becomes alpha x. The limits are x1 to x2 minus integral symbol x1 to x2 differentiation of first function d by dx of dou f by dou y dash integral of second, it becomes alpha x. Alpha dash integration will be alpha x into dx equals 0. So therefore, integral from x1 to x2, so dou f by dou y into alpha x dx minus dou f by dou y dash. Here, upper limit is x2, so it becomes alpha of x2 minus lower limit alpha of x1 minus d by dx of dou f by dou y dash into, so write the integral also. So integral x1 to x2 into alpha x dx is equals to 0. See, already we have taken this alpha x1 and alpha x2 equals 0 in the while assuming the function itself. You see here, alpha x1 and alpha x2 both are zeros. So therefore, so here what we will get it, integral from x1 to x2 dou f by dou y into alpha x dx plus dou f by dou y dash, and this is also 0, this is also 0, minus integral from x1 to x2 d by dx of dou f by dou y dash into alpha x dx equals 0. Video on Monday. So integral from x1 to x2. Now I will combine both. So dou f by dou y minus here d by dx of dou f by dou y dash into alpha x dx is equals to 0. I have taken this alpha x common and the integral also common. So this integral is equal to 0 means only when this is 0. So which implies, so dou f by dou y minus dy dx of dou f by dou y dash is equals to 0. So this equation we call it as Euler's equation.